Welcome YouTubers to the only channel that actually thought it was needed to use artificial intelligence to predict that Mercedes is going to win every single race weekend. My name's Eric, this is R2 Racing, and if you're looking for a video on how this is all put together, you found the right one. In this video, I'm going to cover the three key parts of the project, which is the data gathering, the setup of the AI platform, and the validation of the numbers. And then also, we're going to take a look into some interesting statistics on what would happen if Raikkonen would sit in a Mercedes seat and how would he compare to Hamilton and Bottas. So getting right into it, I want to talk a little bit about the model and how we start. We start with gathering data, and we put the links below on a lot of the sources of the data, but I can tell you right now that the largest part of this project is just gathering the data. To be able to put together these dashboards and these predictions, we had to go into all of the publicly available data we could find on Formula One, and we did find quite a bit. Formula One's website has quite a bit. There are sites like motorsportstats.com and Forex. We are using some of the FIA's data that they publish in their technical documents. So we are leveraging a lot of this information in there and trying to join them together in what we're using, which is the Salesforce platform. Now, this platform we use for several different things, but in this project, we are basically trying to bucket all of this information in specific categories. And the main categories that we want to talk about are circuits, races, race entries, and components, individual drivers and teams. So essentially what we're trying to do is organize all of this data that we're capturing, and we're putting it into these buckets and trying to organize this as we're going to put together these models for artificial intelligence. And if you've watched any of our videos, we're doing currently 4 different models. We're doing a model for qualifying predictions, race predictions, DNF predictions, and fastest lap prediction. So you're able to see everything in this dashboard, from our qualifying to our race to DNFs predicted, and then also our fastest lap. So that's how it all starts to come together, and it really all starts with gathering this data. And there's a lot of data to gather and join together, including statistics like safety car probabilities or how many pole positions someone has. Even calculating averages has been a big part of this project, such as average gap to leader in qualifying and race time in milliseconds over the past 90 days and varying that around. So this project's a lot of trial and error, and the data gathering and cleanup portion of it, it is without a doubt one of the largest parts of this project. It's been incredibly exciting, but it has also taken quite a bit of time in the 6 months that we've been running with this project. So the second part of the project is the setup of the model, and this is where we start talking about Salesforce. Salesforce is the platform that I've been working with for a long time. As AWS has their own platform, which is Amazon SageMaker, we are using what's now known as Tableau CRM, formerly Einstein Analytics, but now within the recent acquisition, now we're calling it Tableau CRM. And essentially that is the artificial intelligence arm of the Salesforce platform. And within it, once we have all of this data, we start looking into the data models that we can put together. So looking into all of the data that we can put together, essentially what we're doing is that we're joining all of that information with what we call recipes. So as we're looking into put this information together, you can see that we're taking all of that information from those buckets that we've organized, such as the race results, the races, the circuits, the components, the constructor information. We're joining all of that together to put one output of final data that we are going to use in our artificial intelligence models. So once we have all of that information set up and organized, then what we do is that we start building what are called stories. And if I go into my Formula One predictions app, we have several different stories here that we're running. I run a couple of others just to see what we're going to do. But the 4 key ones that we're looking are the pole position prediction, the qualifying predictions, the race winner prediction, will they finish the race, or DNF predictions, and the fastest lap prediction. And those are the 4 key predictions that we're using. And here's all of the data that we've created and joined together to use for not only our stories, but our dashboard. So you can see how all of that starts to come together. So I'm going to open a very simple one, which is the qualifying prediction. So once we gather all of the data, what we do is that we take specific criteria, and this is another piece that requires a lot of fine-tuning. And this is where we go from the setting up of the models to the validation of the data. And those 2 parts of the project really work hand in hand. And this is where a lot of it starts coming together. And essentially, in a story, you're basically giving the AI model all of the information that you have, and you're like, okay, well, tell me what you predict or what you can learn from this data that we're providing. So on our case, we are using data from 2010 to present day. We're including all of that information over as we're putting together our models. And as we mentioned, we're including circuit information, race information, driver information, and constructor information as we're looking into what we're going to be doing. So you put it in together in the model, and the model starts bringing together different observations that it finds with the data. So we all know in Formula One, the car that you're in makes a big difference. So in this case, you can see that according to the numbers, Mercedes and Ferrari will lower your qualifying, well, increase your qualifying position because it's looking for the lowest number, but it accounts for 45% of the variation. So if we look into the story, you can see here, this is just a sense of the criteria that we can use. Here's all of the fields that we have. We have actually even much more, but here are the fields that we're using for the qualifying summary right now. And this is constantly evolving as we're cleaning up data, being able to include more data, but we include the constructor, the last name, or the driver in this case, their average gap to the leader. And I know it says this season we've recently changed to the past 90 days as that constantly evolves. The event date, so it gives us some seasonality. And then we also look into temperature. So what's going to be the air temperature like in this race? What is the forecast for the qualifying? So all of that information we take into consideration when we are putting together this story, and we can play around with what we include or what we don't include in order to be able to validate our model. And once that's all put together, one of the things that we study in the model is the degree of confidence that we have in our data. And that is where the name R-squared racing comes from, because we are chasing the accuracy of the models that we have. So presently today we have an R-squared on our qualifying prediction of a 0.59 or 60%. Essentially, you want to get as close to a perfect prediction as you can without getting there. And as we were talking about data, one of the big things, you can see what your top predictors are right here. One of the big things that you have to consider in your data model is also using data that you know before the race. So I won't know what the tires that they've chose for Q1 will be. I can take a guess, but I won't know that. I can certainly use it as a prediction and use it as an actionable item, just like I can put weather as an actionable item, but I won't know that. Just like predicting a race, I won't know when they qualified. I can only predict that, but I certainly won't know where they qualified. So, and I also won't know their race finish position for that matter. That's what we're going to be looking to predict. So you have to use data that is before the event occurs to make your predictions. So we might start doing predictions that are before free practice and then after free practice, so we can take a look into qualifying and maybe even do a couple of videos post qualifying to validate what the race will look like. But essentially we're trying to use all of this information that's available to us before so we can make our predictions, and as of right now we are at a decent level of accuracy to predict the qualifying results. So that is the big piece, and then afterwards is validating all of this information again and again. One of the really interesting things as we're looking into validating, and this is where we're coming to the big piece of Raikkonen. So one of the big things that we can do with Einstein Analytics or Tableau CRM, depending how old school you are in the Salesforce community, one of the big things that you can do is that you can look into particular insights, and then you can also predict what could happen in certain situations. So let's go ahead and look at it as we're ahead of Bahrain Grand Prix, and we're going to look into what could possibly happen if Mercedes needed a new driver at the last minute. Now, we don't know what the average gap to leader would be for this particular case, but let's say in this case we had Hamilton here. And we would be able to say, okay, based on Hamilton's 2020 performance, if the weather holds, which the forecast for the Bahrain Grand Prix is about 25 degrees, and then the weather in qualifying is dry, I don't think it'll ever rain in Bahrain, and then we select our circuit. So Bahrain International Circuit. So the model looks at the score, and it basically predicts that Hamilton will have a score of 2.48. Now that doesn't necessarily mean he's going to be in second place. What the model is predicting is that he's going to be at a 2.48 score. So you have to look at the score of all of the other drivers and be able to make your prediction from it. So if we come back, for example, and we look in, and actually let me just look at it from this prediction. Where are we? So essentially, what we would be looking at would be all of the predictions. You can see Hamilton here and Bottas. I'm going to open both of them. And essentially, you can see what the qualifying prediction would be for Hamilton. And you can see 1.39, where Bottas is 2.3. So every driver will be assigned this qualifying prediction score, and what we need to do then is basically take the order of all of the 20 participating drivers and rank them from 1 to 20. So looking at it from this perspective, Hamilton's at a 2.48 and Bottas would be at a 3.41 without knowing the average gap to the leader for the season. Now, the reason why I don't include it is because we wouldn't know what that would be if Raikkonen jumped in those conditions. Now, if Raikkonen, if we needed to switch a seat, we could use artificial intelligence to predict what driver would perform and how that driver would perform best in a particular situation. So let's just say, for whatever the case, Hamilton or Bottas would not be able to participate in the race, and Raikkonen was the only option for the Mercedes seat. If we switch it around, we can see that Raikkonen would qualify much higher than Hamilton or Bottas, and it would take all of the factors that we put into consideration based on the event date, based on how he performs in certain temperatures, in certain weather conditions, and in that circuit. So it looks into all of those models, and it's able to tell you why basically they would say so. The artificial intelligence believes that in 2020 Raikkonen is slightly below his average form in comparison to all of his past years in Formula One. Basically, it predicts also other fields would have a certain impact on his result. So you can look at it and you can see even the positive factors. So Raikkonen does seem to do well and have a good history in Bahrain. So it says that it will make a difference. Without a doubt, you can see that the car will make a fantastic amount of difference here. So you can see how artificial intelligence starts taking all of these learnings and being able to apply it to the models. So here's a glimpse of how we are putting all of this together. I do hope that you've enjoyed this video. We're going to go a little bit more in depth into each one of the different categories and how specific models put together, but this is a brief overview of how these models are coming along. We'll talk more about different types of models, different algorithms, and things of that nature, but for now, my name's Eric, this is R Squared Racing, and we'll see you on the next video.